the rotor. And that rotor wants to catch up to the rotating field in there. So it starts up immediately. Bam, you hit the button to start it. You'd be surprised how quickly it's up to speed. Where on the other hand, some of the other motors can take longer. DC motors, you can vary them easily as far as startup by putting resistance in there and dropping the voltage to the winding, and it'll cut back on the torque. But if you are not concerned about it cutting back on the torque that much, you can get it to start up slower, get less of that spike being developed as you go through the startup cycle. And from my perspective, that's about let's talk about this just a little bit. Overload relays, we're going to be getting into that in Chapter 8 a little bit more, in Chapter 7. But when we talk about motor overload capability built into the motor, you have two different kinds, one that automatically resets and one that has to be manually reset. You also have some that have to be wired into the control circuit. I've not seen many of them, okay? But then again, that's a little different because if you get there, it's a little more expensive depending upon how big the plant is. So keep in mind that motor protection embedded in the motor can be used in lieu of an overload relay, for example, because its purpose is to shut down the motor in the event of a overload. Same purpose as an overload relay. Okay, several different types, ways of doing it, and again, this is in the posted, I think it was for Tuesday, so you'll see it there. So with this, I'm going to back out of that. And that's it for now. We'll get back with, I'm going to start in with Chapter 7 at this point. Okay? Thanks, guys.